day, everyone. Thank you for taking the time out of your day to joining us here at OnlineTestconf. My name is Bas Dijkstra, and what I would like to talk about is a technique that I think is still sort of kind of undervalued in software testing and in software development. But I think it's a very important part of the work that we do. Um, and I want to tell you a little bit of a story about, as you can see, the title slide says how I improved the tests for restassured.net using mutation testing. Um, First of all, very briefly, restassured.net, you might have heard of it, you might not have heard of it. For those of you who haven't, it is my pet project. It is an open source project that I started about 3 years ago because I'm a big fan of Rest Assured, the Java HTTP API testing library. And over the last couple of years, I found myself doing a lot of work in the C Sharp and .NET space. So I was looking for a library that gave me the same amount of flexibility for writing tests for my APIs in C Sharp, and I couldn't really find it. So I thought, well, let's see if I can create my own. Let's see if I can translate, port Rest Assured into C Sharp. So that is what restassured.net is basically. It's an HTTP API testing DSL domain specific language for C Sharp. It's completely fully open source. It's available as a NuGet package. And as I said, basically, it's a C Sharp port of the Rest Assured Java library. So all the features and the functions and the methods that you recognize and hopefully maybe also like from Rest Assured in Java, you can find those in restassured.net as well. Of course, everything open source on GitHub. So if you want to have a look at the code or the tests or whatever, you can just go to that webpage. So RestAssured.net is a product. It has versions, it has deliveries. Yeah, I create packages and I publish them. And of course, being both a good developer and a good tester, or at least a prudent developer and tester, means I need to test the things that I create. I want to test them before I publish them. And generally speaking, why do we test? We want to inform ourselves or others about the state of our product and any potential problems with it. That is why we test, and we want to uncover information about our product or about the process, and we use tools to help us do that in a more efficient way. So, and that's what we call automation, test automation, and the use of tools to help us perform specific testing tasks in a more efficient way. And the more automated that entire process of developing, building, testing, and delivering software is, the more we rely on the information that our test automation provides us in making decisions about what is the next step for our product in our delivery process. Are we going to say, no, this goes back to the developers because we see a problem? Or maybe we promote this to an integration testing or a staging environment. Or maybe after our automated tests pass, we promote this to production and put our product in the hands of our actual end users. And I'm doing pretty much the same thing with restassured.net. So I have what I think is a pretty extensive set of automated tests. So every time I refactor the code, I fix a bug, or I add a new feature, I've got my automated tests to hopefully rely on. to make sure that everything is working as expected. And when those pass, I too make a decision to publish a new version of my library, push that to NuGet, and essentially make that available to all of the users of the library. The problem is, and this applies to me for Resolute, but also to a lot of the teams that I work with, is that we spend a lot of time developing our product. We spend a lot of time testing the products. We spend a lot of time writing automation to help test the product. But what we don't spend a lot of time on, unfortunately, is making sure that the tests that we write are actually good tests. We don't spend a lot of time testing our tests. Why should we test our tests, you might think? Because those tests, they can deceive us. Our tests can mislead us. Our tests give information, and we need to make sure that that information is reliable, that we can reliably make decisions about the next step to take with our product based on the results of our automated tests. Of course, in a perfect world, every time you see a green check mark, you think, "Oh, that's absolutely wonderful." And every time you see like a red cross or an error exception, or in whatever way your test tool or library or framework signals a problem, you'll think, "Oh, there is a problem with my product." But our tests can be deceitful. They can mislead us. They can give us, they can either send us in a false sense of panic, or they can give us a false sense of security. And both cases, add both cases means we need to do a better job actually testing our tests. And again, I've been working with lots of different teams and companies over the last 18, 19 years. And I see, unfortunately, very little time and effort being spent testing tests. Again, we spend a lot of time testing the product, we spend a lot of time writing the tests, but we don't really spend a lot of time actually making sure that our tests can be relied on. And so the typical ways in which our tests can deceive us are first false positives. Um, False positive to me is a test that indicates there's a product problem when the problem is actually in the test or in the test environment or in the test data, but not in the product itself. A particular subset of these false positives are flaky tests. And so tests that we run and they indicate a product problem or a product failure, and then we run them again with the same data, with the same setup, same configuration, same code, same versions, and they pass. So that's typically a problem with timing, synchronization, or test data, or some kind of downstream service or component not being available. We see these a lot, and especially the larger the scope of our tests, the more problematic this becomes. So what we need to do is test those tests. Find why is this test failing? Why is this test sometimes failing? Why is it not failing other times? What we should not do is what I call sweep them under the rug, or and where rug is short for retry until green. I've seen too many teams, companies just implement like a retry mechanism. For example, my test fails. Okay, let me try it again. And if my test passes, then we'll just pretend like that earlier failure never happened. Please don't ever do that because it means that your test is unreliable. So act on it. Find the root cause, analyze it. In fact, I'd rather have no test than a flaky test, in all honesty, because those flaky, unless you actually take the time again to analyze those flaky tests and use them as input to analyze, well, what's the actual problem here? But please don't just pretend like those failures never happened. The other side of the medallion is a false negative. So a test that just says, oh, okay, everything is right, everything is okay, everything looks peachy, but they let a problem slip by undetected, a problem with your product slip by undetected. And these are what I can a little bit over dramatically maybe call the silent killers because they don't make themselves heard. They don't announce themselves. But this is where the problems start. So you rely on your tests. You think, oh, all of our tests pass, everything is okay. And then there's a product, there's a problem in your product, and that um, is found, is detected by your end users rather than by your test suite.
I think this is also, when this is where QAs are being shouted at for those parts.
Oh yeah, no, absolutely. It is always again, as I jokingly but also sadly say, um, when the product works fine, it was well developed, and when it doesn't work fine, it was badly tested. Oh yes. So one of the metrics that we tend to rely on when we talk about the quality of our tests is code coverage. But that's not enough. Let me give you a very quick example. I've got a small code base here representing a bank account and a bit of logic that adds interest, which says I can really only add interest to a savings account. And I've got a test. It is a super simplistic example. The point is not the code, the point is the principle behind it. I've got a test passes, 100% code coverage. Amazing. Test pass, 100% code coverage. What more could we wish for, right? The problem here, though, is let's say a developer comes in Monday morning, has had a brilliant idea over the weekend, and says, "Oh, I'm going to refactor, rewrite, improve the code, and I can do that safely because I've got my automated tests as a safety net." And they accidentally, or hopefully accidentally, rewrite the code and rewrite that if statement to always evaluate the true. They think they've improved the code, but they introduced a mistake. And they relied on their automated tests as a safety net to tell them, oh, is there any kind of problem here? But all these tests pass. The tests still show 100% code coverage. But that bug that we just introduced makes its way to a production environment, meaning that now we cannot just add interest to savings accounts, but also to checking accounts and other types of accounts, which might be nice for the customers of the bank, but not necessarily for the bank itself. So this again, it's a very simplistic and quick example, but it hopefully shows you why just relying on code coverage as a metric or as a means of talking about the quality of the tests that we write is probably not such a good idea. As Martin Fowler expressed this, test coverage is brilliant at telling you what code you haven't tested yet, but as a means of as a quality target in and of itself, it's pretty useless. And why? We want to make sure that our tests fail, or that our test can fail. In fact, whenever I write new tests or whenever I help others or teach others to how to write tests or how to write better tests, this is one of the first things that we talk about, or that I hope they think about. Can my test actually fail? Because when it doesn't, when I write some test code and it compiles and it runs and it produces a green check mark on the first time, that's the time to start asking questions. Did we actually test the thing that we want to test? And in case of a change in the behavior of a product, will our tests detect that? This is and again, hopefully that example on the previous slide showed you why it's probably a good idea to make sure that your tests can actually fail. And that's where mutation testing comes in. Mutation testing is a technique supported by tools to help you find out, can my tests actually fail? Are my tests capable of detecting certain kinds of changes in the behavior of my code or of my product? So again, back to restassured.net. I was at some point somewhere last year, so I thought, I've been doing this, I've been developing this for a while, I've been relying on a set of automated tests for a while, but how good are those tests actually? Can they fail? Am I covering everything I think should be covered? What I added to the project and to my workflow is a tool called Striker.net. And Striker.net is a mutation testing library for C Sharp. So how these mutation testing libraries work is they inject small changes into your code. They create mutants in mutation testing terminology. And a mutant could be a binary operator that is changed from smaller than to smaller than equal to or to greater than, or they negate an equals expression, or they remove a call to a method, for example. And what these tests, so that is the first step in the mutation testing process, creating these small changes in your product code, or rather in-memory copies of your product code. So it doesn't actually change how your code behaves, but it creates in-memory mutants. It then runs your test suite and sees if there's at least one test that detects the problem, that detects the change. If so, that tells you more about, that gives you useful information about the capability of your test suite to detect certain kinds of problems. Um, every major programming language has at least one and often multiple different mutation testing libraries. Striker.net is the most popular and most sophisticated one, as far as I know of, for the C Sharp ecosystem. So that's why it was a good choice for me for this case. It's open source. Again, I like that. Easy to configure. If you want to know more, this is a great resource. Just Google Striker.net documentation, and this will probably be one of the first Google hits. So again, as so what Striker.net does, if you run it, it will create mutants. So in my case, this is the output or the in process output for a mutation testing run on the restassured.net code. It creates 538 mutants, which means that my entire test suite will be executed at 538 times. Mutation testing is a time and resource intensive process, which is definitely something to keep in mind before you start adding this to your project. And for every one of those 538 mutants, my test suite is going to be run. The good thing is um, the tests run really fast, and Striker is really efficient. But still, this entire process takes about 5 minutes. So it's not too bad actually, but it's also not a huge code base. And after that, it will produce a report telling you, oh, this is the amount of mutants that were killed, meaning there's at least one test that detected the change that I injected. And these are the mutants that survived, which means um, you probably want to look into this. To give you an example of what that looks like, I'm not going to do the actual test run because that will take a little bit too long, but I've got an example of the output right here. This is a striker.net report. Let me zoom in a little bit so everybody can read it well. And this is what it told me about a certain kind of. So, one of the capabilities of Rest Assured is the ability to deserialize a JSON or XML response body into a C sharp object. which is easy for response post-processing. Um, so what I didn't really cover, apparently, was the situation where what happens in my what I didn't really cover in my tests properly enough is what happens if I try to deserialize an empty response body. And that should throw a deserialization exception. That's the behavior implemented in rest assured. Um, but I didn't properly test that. So, for example, if I would refactor or rewrite this logic, I didn't have the proper tests to make sure that all the behavior was still in place, all the desired behavior was still in place. And so, what an example of what Striker.net does is change this logical or to a logical and, for example, that survived, which means none of my tests picked up on that. And if the response body was not empty, but some kind of string, I also didn't really have a test that would detect that change. So that led me to adding more tests to this specific for this specific logic. So I added a very specific test that tried to deserialize a response body that was empty. So, um, and assert that it throws a deserialization exception with a very specific exception message. So that this is a test that I didn't have before, but that I added based on the feedback that the mutation test, my mutation testing tool, Striker, told me. You're not testing this piece of logic very thoroughly. It might be a wise idea to add some more tests. So I added this specific test, ran the mutation testing again, and afterwards it told me, oh, now all of the mutants and so this one, two, and this one are actually killed, meaning that you now have at least one test, and that's this specific test to detect that will fail in case you accidentally change the behavior of this piece of logic, which gives me much more trust in my tests around this specific part of my logic. Another quick example is no, I'm gonna skip this one. Just because of the time, I want to be respectful of everybody's time here, and I see we're coming up to 9:30 my time. But this is just one of the many examples that I could give of the kind of output that a mutation testing tool gives me. And so it changes parts of my application code, my restassured.net product code, runs the tests and see if at least one of the tests failed because of that change. If you want to read about some other of the things that I've found and the things that I've learned using mutation testing to analyze and improve the tests for restassured.net. This is a blog post that I write. I don't know if you'll publish all of the slide decks somewhere or the links, or if there's another way that I can get all of these links to the people
We
who
will
attended.
definitely be we will definitely be sharing the slides, the recording, and the recordings along with the slides. Uh,
Excellent.
um,
Excellent. Thank you very much.
for that, but I also want to mention, Bas, since we stole a few minutes of your time, if you do want to show that example, because after you we're going into a break, that's also fine. We can shorten the break if
No, it's more of the same example. So
okay.
I'd rather spend the last couple of minutes talking about, um, well, what if I want to use this? I've got some advice there. I think that is more useful than
100%.
examples that are more of the same. Again, people can always read up on it. All of these examples are in this specific blog post, and there's plenty of others too. So this is something that but mutation testing is that really for us? It's only for unit tests. Um, That is definitely not true. So, for example, the tests that I use for restassured.net, they are not unit tests. They are integration tests. They make actual HTTP calls to a mock server using the restassured.net code. I've got plenty of other examples too, and in workshops and with clients, where mutation testing is used for integration and acceptance tests too. The only thing that is important to keep in mind is that, again, if you have a large code base and a test suite that takes a long time to run, mutation testing time at the time it takes to perform mutation testing is going to increase significantly. But as long as you have a suite of tests that runs quickly, or relatively quickly, mutation testing is definitely something that you can use for not just for unit tests, but also for integration and even acceptance tests. Um, should we kill all the mutants? Should we strive for 100% mutation coverage? I think the answer to this is probably not. And just like with all kinds of coverage, at some point that law of diminishing returns is going to kick in, and it's going to take you an extraordinary amount of time to cover those last few edge cases. So setting an absolute target for this, if it's 1995 or 100%, I don't think that that's a very good idea. What I do like to do with these coverage metrics, and mutation coverage is no exception, is just monitor it over time. If the coverage is going up, you're probably going in the right direction. If coverage is going down, it's probably time to start asking questions. And again, mutation testing coverage isn't really, and again, mutation testing coverage is the percentage of changes that a mutation testing tool makes in your code that are detected by your tests. Is mutation testing for you too? Well, I think so. I think it is a very useful way, a powerful way, an automated way to help you test your tests. And if there's one thing you take away from this talk, it's not anything about Striker or Rest Assured. I think it is important to test our tests. And mutation testing is a technique that can help you get more insights into and confidence in the test suite that you're using to find important information about the product that you're building. If you want to get started, um, I'd say start small. All of these tools, you can configure them to say, well, only change this part of the code and then only run this subset of the tests. So start small, because these tools, they tend to produce a lot of information, and somebody has to go through all of that information and see, oh, this is useful, or that is maybe not so useful. So start small, see if the information that you get from a mutation testing tool is actually valuable, and see how it helps you improve the quality and the defect detection power of your tests. It works particularly well for the parts of code that implement business logic or business rules. So if you have if statements and those smaller than, larger than, equal to, not equal to, and those parts of your code, that is where mutation testing shines. And that is typically the parts of your code where, well, the important decisions are being made. So you want to make sure that your tests are properly covering those pieces of code. And that is definitely where mutation testing shines. So because it is so good at creating small changes in those parts of the code and then running your test to see, well, did I actually cover this properly? Um, I said this for the previous slide too. At the absolute numbers, at the numbers of your mutation coverage, the number of mutants that were generated and that were killed, don't focus on those too much. Track improvements and how those metrics evolve over time, and see if you're going in the right direction and if it's actually helpful, of course. Um, and especially, I wouldn't make this part of a build pipeline initially because, again, it is a pretty time-consuming process, and B, someone needs to analyze the information that is produced by your mutation testing tool, which again takes a lot of time and might uh, and it doesn't really make a lot of sense to produce the information but then not use it before you make a decision on how to what's the next step in your delivery process, for example. So definitely do it on a regular basis, but at least not I wouldn't initially add it to my build pipeline. Maybe at some point in time you get to a point where you say, yes, I do want to add it to my build pipeline. Would I do that right away? Probably not. To wrap up, one final thing to remember, I think code coverage um, really only tells you something about the amount of code that your tests invoke. Mutation testing is great in helping you find more information about the kinds of problems that your tests might catch. But in the end, we need humans. We need human brains to decide, well, all those tests that we run, those tests that we add, those tests that the mutation testing tool tells us we should add. It takes a human. There's always a human in it requires a human in the loop to decide, well, is that information actually valuable? Is the test that we're supposed to add here, is this actually valuable? So mutation testing 2 is not going to replace that. It's a tool to help you support testing your tests, but it's not a replacement for, again, that human brain and human judgment. If you want to just try it out for yourself, I've got a couple of workshops that I've been running quite frequently recently. So this is a link for a repository in Java, and this is for a repository in C Sharp. Though both repositories contain a fully functional REST API with the database and everything, controller service, the works, and a set of acceptance tests, and a mutation testing tool that you can run, analyze the reports, and use the information from those reports to improve on the code. And this is just a ready to go. These are two ready to go repositories. If you want to test, if you want to see practice with mutation testing for yourself. And again, these are just free, open source, public workshops. So by all means, feel free to check them out. That's it from me, May.